Hi, everybody. Today we're going to talk about Ethernet over VPN bonding. Previously, we talked about Ethernet over VPN. So today we're going to talk about Ethernet over VPN together with VPN bonding and combine both technologies as one feature for some special organization needs. So let's briefly go through the Ethernet over VPN technology again. So what Ethernet over VPN does is basically we're going to build a VPN tunnel across any layer 3 WAN, wide area network, can be public internet or MPLS. So we build this layer 2 VPN tunnel is actually using SSL VPN encrypted. Then we bridge the tunnel together to the LAN side of the CMG, which is typically the data center or HQ network. Then on the remote side, we bridge the tap or the tunnel interface to the LAN side of the remote network. So essentially, we extend the HQ to the LAN in a layer 2 network. So that means both sides feel as if they are in the same network, in the same network subnet. So that's what Ethernet over VPN works. So the VPN bonding, there's two ways of VPN bonding. One is OSPF, which basically we have VPN tunnels and we run dynamic routing and let the dynamic routing protocol to take care of the load balancing. But that's really routing across to network. There's another form of VPN bonding is using LACP, Link Aggregation Control Protocol, which is a standard protocol to combine, which is traditionally used to combine two physical interface into one logical layer 2 interface. So we can use the same technology to combine two layer 2 tunnel into one logical bonding interface. Then we bridge that bonding interface into the LAN side from both HQ and remote. So this is how it looks for Ethernet over VPN bonding. So we're basically going to combine both technologies together. So first of all, we're going to have two VPN tunnel, and we're going to combine them into using the bonding technology to combine them into a bonding interface. So this bonding technology will take care of the load balancing and failover between the two VPN tunnel. So the VPN tunnel on the remote side will map to multiple or rather dual internet connection, especially if you're using the HSA L2. So we can map each tunnel to each SIM card connection, or if you have physical connection, you can map the tunnel to its respective physical fixed line connection. Doesn't matter. So once we have the VPN tunnel built up, then we form them into a bonding interface. Then we use the bridging layer 2 bridging technology to bridge the bonding interface to the LAN side of the CMG on the HQ side. So similarly on the remote side, we bridge the bonding interface to the LAN side of the HA side. So essentially, we extend the layer 2 network from remote to the HQ or vice versa over a public WAN using redundant connections, whether it's dual WAN or one SIM with fixed line, doesn't matter. So we can build multiple VPN tunnels and bond them into one logical layer 2 interface and bridge them to the LAN side. So essentially, we are getting the best of both worlds. So that's how it works. So I have this box here with me, but I'm going to add it into mFusion to push the config remotely from mFusion. So there are existing configurations. So what I would do is I need to remove the existing config so that I can push a fresh config. So in order to push fresh config from mFusion, I need to add the host into the mFusion and apply the config push. So I'm going to get a MAC address of the device. So I have already logged into mFusion. I'm going to add a new host. So I just go to the same step of how to push config as well. So this is a good opportunity. HSA template, you can optionally apply location of the device so that you can see this in Google Map later. And so now once you assign this device to the respective entity, you can actually see the configs from that entity, because I have already upload the config to the demo entity, just in case if you need to see. So whatever config I apply to the entity will be available to the host. You can apply using this approach. So whatever config apply here will be available to the host that's been added or rather assigned to this entity. So I've just add this host. I'm just going to give a name so it's easier for me to recognize later. So I'm going to push the demo 4 config, which is actually in here, which I'll go through the config later. You can come to the online documentation ransnet.com and demo 4. So the config is attached at the bottom as well, just in case if you want to try yourself. So I've already attached the config, so I'm just going to push to this host. But before I push, I need to, what I'll do is I will write erase because there's some existing config. If it's a fresh box, it's okay. So I'll reboot it, and on the Enfusion side, so the box will put up with a fresh config, and on the Enfusion side, I have already pushed a demo config. So later when this box comes up, it will actually grab the config, the demo 4 config, and reboot again to apply the config. So while we're waiting for the box to boot up, I'm just going to walk through the configs, which will be available later once the box grabs it. But because it takes up to quite a few minutes to boot up and grab the config and reboot again, so I'm just going to go through the config with you first. So on the CMG side, which is on the hub side, so you need to configure the SSL VPN instance. So basically, each instance is one tunnel. So you can have, normally we can have multiple clients for each instance. But for this case, because we're going to do point-to-point bonding, bonding is point-to-point. So that means each VPN tunnel on the HQ side is only able to, we should only talk to one tunnel on the remote side too. So if you have one HSA at the remote side which has 2 tunnels, then you need to have 2 instances of server instance on the CMG. But if you have another HSA at the remote end, that means we need to have another set of server instance, for example, 3 and 4 and 5 and 6 and so on, so that you need to have a pair for each remote HSA, because we're going to have the tunnel to assign to a bonding group, and the bonding is point-to-point. So once we have the bonding, once we start the VPN server service, so let's just going to go to the I'm going to go through that VPN server config later because I can't remember the IP address. Try my luck. No. Okay, never mind. So we'll go through that config later on the CMG. So just look at the boot logs from the. So it looks like just now when the CMG, the HSA boots up, you already grabs the config from the Enfusion. So this time when you boots up, you should be fully loaded. So on the CMG, you have that a pair of VPN instance configured for the each HSA. Then we will have the bonding interface assigned to a group, bridge group, which is in the same as ETH1, so that you basically bridge the bonding interface to the LAN interface. So I've configured IP address on the bridge interface so that I can pin from my PC later, because I have no other PC at the other end of the CMG. So similarly on the HSA, we're going to have the bonding interface and assigned to the bridge interface, assigned to the same bridge as the LAN. And for the tab, we're going to, once the tab starts, you will be assigned to the bonding group 0. So this section means what this does is basically to map the tunnel, because on the CMG or on the VPN server side, we're going to have different ports for each different tunnel, for each respective tunnel. So in here, we're going to have a policy-based routing config. Previously, we used to use multi-WAN or the load balancing config to do the policy-based routing, but this is a simpler approach. So we're going to have a firewall to mark the packet, which is destination to 1443. Remember, we're going to use output. That means it's for the traffic originate out from HSA. So typically we use firewall set access. That means it's for the traffic passing through HSA. So in this case, it's going to output from HSA and going to destination 1443. And we're going to mark with a value here. And we're going to apply this to a policy-based routing rule. So that means whichever is going to the traffic going to destination 1443, you're going to use this LT0 as the exit interface. That means we're going to map this tunnel 1 into LT0 and tunnel 2 to LT1. We're going to do a TCP dump later to verify this. So now let's go back to the HSA. So now we do a reboot and we do a show config. So it has been pushed with the config, already has grabbed the config from Enfusion. So let's verify is the same config that we have pushed down here. This is the config we pushed through, and you can go to the entity to verify that. And this is the startup config. And this is what we see from the console. So it's exactly the config that has been pushed down from Enfusion. You can also monitor the operating status. This is the device we added, and you can see live data here. So to verify the config's operating status, the config has been pushed down. We just make sure the operating status match what we intend to, or rather match to what we have configured. So interface bound 0. So because we have assigned the tab 1 and tab 2 to bound group 0, so if you show interface bound 0 here using this command, you will see tab 1 and 2 is both slave of bound 0. That means these two are assigned to bound 0 interface. And because we're going to map the bound 0 to bridge group LAN, which is to be the same as the HSA LAN side, so we just verify the bridge LAN, and you can see that there are two interfaces, bound 0 and ETH1. ETH1 stands for the LAN side of the interface for HSA. So that's basically working as it is. And if you do a show IP interface, we really don't have IP address for bounding 0 and also no IP for tab 0. And if you look at the config for the server as well, we don't assign any address pool to the tab interface because these interfaces are going to just run as logical layer 2 interface only. So the IP is supposed to assign to layer 3, but optionally you can assign IP address to the layer 2 interface, for example, to the bounding interface so that you can pin to each other, but in this case, it's not necessary. So because I've already assigned IP to the bridge interface and 0, and on the server, on the gateway CMG side, I have assigned IP to bridge 0. So this is basically, and both sides are on the same network, or 30.1.1. And I'm going to try to pin, because I'm using .1, so I have assigned .2 on the CMG side. I can pin. So I'm really pin, you know, the LAN side of this HSA and the LAN side of the CMG are in the same subnet, and we can pin across. We can pin to each other across the tunnel, and which is bounded under bound 0. So, and I've plugged my PC in this HSA, so I'm just going to verify as well. I have already configured my IP to 30.1.1.7. So I'm going to pin to the CMG. So I can pin the same. So that means the layer 2 tunnel is up and running. So if you want to verify the tunnel is really going through the respective LT interface, you can do a TCP dump on the SIM1, which is, or the LT0. You can actually all the packets going to destination 1443 is going through LT0. And if you TCP dump on LT1 and the other tunnel, which is 2443, is going through LT. You don't see 1443 here. So that means the traffic is equally split between the two LT interface. And this is exactly as per what we configured here. So anything goes to 1443 is going through LT0, and the other one is going to LT1. So we just do another verification to say that here there's traffic going through the tap interface or the bounding interface. Because the traffic is supposed to be going through the bounding interface across the two tab now. So on this tab here, on the bounding interface, I'm saying my PC pin to the other side of the HQ network. So if I can actually SSH into that CMG now because I'm having access to it. So you can actually see the traffic going through the bounding interface. So I'm able to go into the CMG too. So if you do the same showing CMG on the show interface bound 0 on the CMG, you can also see tab 1 and 2. And similarly, if you show bridge 0 and bound 0 and ETH1, because this is what I have configured. I've allocated bound 0 to tab 1 and also bound 0 to interface bound 0 to bridge group 0 to be the same as ETH1. So, and you TCP dump here on the bound 02, you'll be able to see the traffic coming from here. Or you can see bridge 0. I'm actually trying to SSH and also add a pin. So all the traffic is going through that bounding and bridge interface now. Okay, that's all for today. Thank you very much for watching. And during your free time, you can try to connect to the HSA UI to basically to try to do your failover. You can simply stop and connect the interface. You'll see the traffic is being auto failover or other load balance when both are active. And there's another interesting command is, so if you can track the interface, configure this command to track the interface of the physical HF or the HSA physical interface so that the failover is faster. Otherwise, you have to wait for the tunnel to tear down, because after the tunnel detects the tunnel will detect the physical interface, and after a few tries, you will tear down the tunnel. If you put this command, you can tear down the tunnel immediately so that the failover is faster. You can try that on your own. That's all for today. Thank you very much for watching. I'll see you again in next session.